What is Flatline Robotics' vision for classroom and kids?
The Flatline Robotics vision for classrooms and kids is a collaborative learning environment where students are able to direct their own learning towards their specific interests in STEM, right? So the offering of the Intro to Robotics class is the beginning. It gives you the foundation, the basis that you need in order to move forward in robotics, automation, mechanics, electrical, software. Kind of gives you it's a quick summary, right? It's a short class. It's only a couple of months long, and it touches on all of the bases for what is a robot, introduction to mechanical systems, introduction to electrical systems, and introduction to autonomous systems, right? Because those are the three things that really define robotics. One is interaction with the physical world. Two, it's an electrical digital system almost always. And three, it is a very software intensive thing, right? Because in order to solve a technical problem with robotics, you have to have a process for it to follow. And that process is encoded in software. And so you have to have the skills required to break down a problem into its component steps and then implement those in a way that will allow the machine to perform the task.
What makes robotics one of the most important skills a student can learn right now?
Because robotics is not just one skill. Robotics is many skills. It's problem solving, it's process investigation, it's programming, it's engineering. And the world is changing before our very eyes. We all just saw Neo come out, and we've seen the bubbles at Quick Trip and the Bella dumbwaiters at restaurants. And this is just the beginning. There's a long history of industrial robotics, right? The Canuck, the big arms that put cars together and weld things. But the world of consumer robotics has been kind of a fantasy for a while now. I remember as a child, I'd gotten a Robbie the Robot. This was like a janky toy that I got when I was 6 or 8. And I'm like, oh, cool, a robot. And it had a little tray. But all it was you had a controller and it would RC. Right, you could turn left, right, go forward, backwards. That was all it could do. I'm like, this is not a robot. This is an RC car. Right? Which is still cool. But it kind of got me interested in it. And then I pivoted to software, right? And so I've been doing software for a long time. And I got into robotics because what's the future, right? We see it everywhere. There's no getting around it. They're going to be dropping so many of these machines on us in the next years that it's going to be unbelievable. Like I can name a handful of them. We've seen them, right? We know them. But in 10 years, it's not going to be that. There's going to be 2,000 different manufacturers of these things. We're going to be importing them from every corner of the earth. They're going to do all sorts of stuff. And people are going to need to know how to build them. They're going to need to know how to fix them. They're going to need to know how to break them. Right, so we're going to have all of these machines that are now in the public circle. And I don't know if you've seen some of the videos that come up, but these machines don't always work right.
Right.
And people are going to have to know how to deal with that. And everybody's going to have to know how to deal with it, right? Children are going to need to know that, oh, hey, it might be cute, but that's a dangerous piece of equipment. They're all dangerous pieces of equipment. Right, there was a video, they were showing off some boxing robots somewhere, and they got a whole bunch of kids like sitting around in a circle, and one of them just goes buck, like it falls down and just starts flailing, and you see it like inching towards this child, it's like backing up in terror. And so people are going to need to know how to deal with those situations, and by having a population that's better educated on what they are and how they work and what they do will be better equipped in general to deal with them. And it's going to be the job of the future, right? Not everybody gets to be a rock star engineer or a lawyer or whatever. Some people end up as mechanics. Like these are the trades that are now not worried about their jobs, right? Mechanics, plumbers, electricians, right? Electricians are in demand, air conditioning people are in demand, plumbers are in demand. Why? First off, apart from the fact that robots can't do that work, now they want to
Right.
build all these data centers to AI, and they're going to be full of these people who have to be master electricians and master plumbers in order to do this work. And the same thing is going to be with robots too, right? Amazon has all these robots in their warehouse, and it's hard to find people who can work on them because not everybody has that skill set. I know lots of software people, and I know a bunch of mechanical people, and I know a whole bunch of electricians, but the full like multi-skill skill set is usually not there.
Right.
Right. And some people will know one or two, but not like the whole gamut. Right. So
Okay.
in order to know robotics or to be a roboticist, you have to be able to do the mechanical engineering, you have to be able to do the electrical engineering, and you have to be able to understand the control systems, right? Because I know that AI is the buzzword today, but a lot of these robots are going to be built and that need to be built, need to be designed. They're not going to run on the magic AI. They're just going to be normal algorithmic processes, right? You don't need it to be able to write Shakespeare if all it has to do is move something from one thing to another, or clean the snow off your driveway, or clear some tubing or something, right? It needs to have a much more limited set. And that doesn't mean that you never use AI, but it's such a buzzword, right? And you absolutely have to learn things like computer vision, which is it's bundled in AI now, and like machine learning, like which is also bundled in AI. But like in order to perform things like clustering, object detection, process management, right? Because you can train the AI to do all sorts of things. So, well, let me just start that over. There's a bunch of different models in AI that do different things, and some of them are relevant to robotics, and some of them are not.
Right.
So you have to know about AI in a way, in such that you know what tools are available. You need to know that you can pick an image net if you need to recognize objects, but you'll almost never have to deal with the hype train that is going on presently with things that talk to you or hallucinate.
Why did Flatline Robotics decide to create the Intro to Robotics course, and what gap do you see it fills?
The Intro to Robotics course it's not something we created, it's something we got from Rev Robotics, who is one of the two primary vendors for FIRST and FRC. They put together this as a package that they could, to get people ready to compete in those leagues, right? The FIRST and FRC, like what's called FIRST Robotics Competition. It's the largest robotics competition, right? And every year they come up with a game and people build robots to solve it. It's really cool. And definitely worth checking out. But we're kind of going in a different direction. One, we really like competition robotics because it gets people together as a team to solve problems collectively, which is what we want to do as Flatline. So we do the Intro to Robotics course to give you that intro to robotics so that you have a survey of all the topics surrounding robotics so that then you can enter a collaborative learning environment. There's a lot more to learning than being lectured or doing homework. And I found that I always learned better when I was doing something for real than when I was doing an academic task. When like you go to college and you study and you might do one real project at the end of it for a capstone. When you have a engineering job, you do 2 of those a year sometimes, 3, 4 big engineering projects, and you don't work on them alone. So the point of the collaborative learning environment is to get kids used to working collaboratively, creatively in an engineering environment.
Okay.
So I've called it peer led in the past. It's not so much, you're not learning, I mean, you're always learning from students, right? That's one thing, right? You learn from your other students, you learn from your teacher, you learn from everybody. But it's not so much that you're learning from a student, it's that the students are collaboratively deciding what to learn, right? So after Intro to Robotics, we'll hand you a couple of projects, like simple projects to get your cohort up and going. But after that, it's what do the students want to learn how to do? What do the students want to work on? Because if there's one thing I've learned, it's that people who are often new to something have, I mean, a lot of times they have really bad ideas, right? But a lot of times they have fresh ideas that haven't been seen or heard or discovered.
Right.
And to have an environment to cultivate those ideas into reality and maybe even to commercializable products in the future, but to do it with a team, to do it with supervision that's professional, and to have access to the resources you need to complete hard projects, right? I don't expect a fresh cohort to know how to manage projects. I don't expect a fresh cohort to know how to take something from an idea to reality, right? But by the time you've done this a couple times, you will be proficient at it, and people will find their molds. Like they're a really good project manager. They really excel at autonomous systems development. And that's kind of what I want to cultivate, because there's lots of different types of people in this world, and lots of people, I imagine, will come, they'll take Intro to Robotics, and they'll check out, and that'll be it. That'll be cool. That was fine. But the people who are in it, the people who find their passion, the people who want to be engineers, those are the ones who I really want to reach and give them a vehicle to grow as engineers, and maybe even have a vehicle to develop their ideas and their dreams, right?
If a parent is watching this right now, what is that wow moment you just referred to that a kid will experience in this class when they get it?
You know, it's going to depend on everybody. It might be as simple as hooking up a motor and seeing it spin, and, you know, knowing how, that's how that works all the way. Or it might be writing a program that controls the device, or wiring up a circuit. Like doing some of the, like it's everybody's different. Like in combat robotics, a lot of people, their wow moment was just watching a video on YouTube and going, I want to do that, right? And so until you know it's there or about it, you can't really get excited about it, right? Until you have these fundamental understandings. If you're not already an engineer, or you know how to program, or like technically minded, you have no idea how any of this works. Right?
Right.
It's so you can't expect people to just be super into it until they understand it a little bit. Like, we all saw robots as kids and thought they were cool, but like the aha moment wasn't until I started getting a lot more detailed in it, right?
So, take me into the hands-on building process for a second.
So there's a lot less building than you might think, right? Because it's an engineering project, and if engineering projects were all about writing code really fast or assembling a thing really fast, then it would be a much easier job.
Right.
There is hands-on work, right? So in the introduction to robotics class, the first thing you do is put the class robot together, right? So there's the kit, and you assemble the kit, you understand how it works, you install the servos, you load all the brackets up, you build the structure with wheels and a lever and those things. And in the Intro to Robotics class, the hands-on build process will be very straightforward, right? We're going to be using components that are manufactured, and we're going to be assembling them. So you will bolt things together, you'll connect wiring connectors to each other, you know, very basic stuff. But you follow instructions, you build a robot. That is there to give you an idea, right? This is the survey. We're looking at what we're doing. When you go to the collaborative learning, it's going to be a much different process because the thing you're building may not be out of the kit. In fact, ideally, it's not. You will be designing parts in CAD. You will be 3D printing parts. We will be having parts machined from our partners, right? If you need a part that's metal and we can't make it in-house, we have to have it subbed out, right? And so we have friends and partners in the industry locally who do that work for us. So you may design a part, but it may be next week before you get to see it because it had to come from Halsey and Denton or Franklin or whomever we're working with that day to make these parts.
Right.
Like we'll do, like Trace will do plasma cuts for us. Halsey will do CNC work. Like there's different partners that we have to make different components. In the intro to robotics class, it's all bolt together. It's all pre-made. But the goal is to get you to a point where you don't need that, right? I love off-the-shelf stuff, and we use a ton of it. Like if you go on Amazon, when I was a kid, the idea of learning how to program microcontrollers was an expensive one, right? Because you had PICs were the only thing you could get. They were $70, $100 for one of these microcontrollers. Are you gonna make a light up garden gnome with a $100 microcontroller? No, you're not. But when you can get a Wi-Fi connected microcontroller for $3 brought to your house that day, your ability to experiment and create goes up rapidly. We've reached a point in logistics where I can have anything. Like we can design a car and I can have all of the parts delivered to my house inside of 30 days. Like everything cut and made in different places and shipped to me. So we live in a just-in-time world, and that's one of the things that makes making, like as a maker, so awesome these days. Because roboticists are makers too, right? And it's almost, you almost want to think of yourself as a maker first, right? Because not everything you make is going to be a robot, right? You know, you might not build only robots. You might build whatever. You know, you might, maybe some other part is your passion. You might like making model airplanes or drones or unmanned, well, I guess those are all robots too. But you know what I mean? There's lots of different things that people enjoy making. Some people may just like to make art. Intelligent art, like robotic art, is amazing. Automata have been around for thousands of years, right? It's just another form of robotics.
In the class, in that first week, what are students actually doing as far as what they touch, build, what they experience?
The first week is very much learning what is a robot. You'll be assembling brackets. You'll be building the superstructure of the class bot, and you'll be learning about the different parts of a robot. It's very much day one stuff in the first week.
Okay.
So the course goes intro to robotics, intro to mechanics, intro to electrical, and then intro to autonomous systems.
Okay.
Which is like process control and stuff. So the first week is introduction. You assemble the class bot. The first several weeks is building the bot, right? And learning the fundamentals. What's a sensor? What's a control? What's a process? You know, and we'll introduce some software concepts in the beginning and then in electrical. That way it's not completely foreign when you reach autonomous systems. Because software is a big thing. It's a big part of robotics. You don't have to be an expert at it to do a lot of robotic stuff, but for autonomous controls, you do have to be an expert at it. And so we want to give you as much of a head start on that before we reach that section as we can. And not everybody's going to be an expert on it, right? Like I said, this is a multidisciplinary thing. So there's lots of room for people who maybe they're really good at mechanical, but not so great at electrical or software. You know, and there's someone who's like a software wizard will be fine just being a software wizard, right? Same with electricians. But the goal is to make sure they have at least enough of a survey of all of the aspects and not just being pigeonholed into one. Right? They need to know what they don't know.
And in 3 months, they're going to get
a very basic
of all those different categories.
Yes.
Why do you use Rev Robotics kits specifically? What makes them special?
Well, there's two vendors, right? They're both here in Texas. One is Vex and the other is Rev. And Rev is I got into robotics properly via combat robotics. And Rev is, they've fielded combat robots, they host tournaments, they've, I mean, well, just get cut to the track. I like their friends. Like met Greg Needell at the Dallas Makerspace right when it founded, like 10, 12 years ago, right? 13 years ago, a while ago, as he was just starting that company at the time. And that like everything was kind of new, right? Like we hadn't had the big push in technology that we had in the last 10 years. So there was like a sea change that happened with technology, like in the early 2010s. I don't know if you noticed it, but it got real cheap and real available, and drones happened, right? So it's a lot happened really fast that made everything kind of start to snowball. And so having known those guys, I know that they're good at what they do. Their whole staff, like a bunch of their staff are combat roboticists and stuff. Like they make good stuff, right? I have a lot of friends who work there. I only have one friend who works at Vex. I have a lot of friends who work at Rev. At the end of the day, that's really what it is I know I can get support. I have direct access to the engineers. They're great people. They support our community, right? They're a lot closer. Vex is in Greenville. Rev is in Carrollton, right? They're just good people. Also, they give us a real curriculum, right? So they created this curriculum, Intro to Robotics 1, which meets, like I think the initial target audience was high schools, right? Because it meets all of the high school criteria for such a class, like I think it's TEKS, TEX standards. So like I have with the class, it tells you what lesson hits what. And it's not really relevant for us, but it is for like any colleges or high schools who want to run that class. It meets their standards so that they can operate it.
Nice.
But it also is a good foundation, right? I've gone through it and it covers all the bases that we need, right? Because it's there to kind of get you ready for FRC, which is another problem solving, right? It's the competition.
How would you say this hands-on building helps students understand engineering better than, say, textbooks or online videos in a typical intro engineering course?
Well, it kind of changes. So up in Tulsa, the Intro to Engineering class has you build a combat robot now. They changed that. So it kind of depends. Some classes are getting more hands-on, but this is definitely hands-on. It's not Intro to Engineering now, because Intro to Engineering covers different subjects than this. This is Intro to Robotics, where we cover these 4 things specifically. What's a robot? Introduction to mechanical, introduction to electrical, and introduction to autonomous systems. Introduction to engineering is usually more on the thought process of engineering and engineering projects and thinking about design criteria, stuff like that. Whereas that is something that we're going to do a little bit more hands-on, right? Because it's going to be, I mean, I'm not saying that colleges don't do it hands-on, but it's going to be almost all hands-on with us, because you really start doing intro to engineering once you finish intro to robotics, because you get these skills that make you useful in the minimum sense, and then you start trying to solve real problems. And engineering is solving real problems with technology. The projects that you run, and especially when you're new, it's going to be hard for a brand new cohort to complete a project in 1 or 2 weeks, right? Unless it's very simple. But if you take a whole bunch of people who are coming out of intro to robotics, you give them a problem like build a robot that shovels snow, it's going to be more than 2 weeks for them to solve that. They don't know what they don't know yet. We've only just given them the very basics, and that's where the having the instructors there is for, because you can go talk to people who've built real robots and get ideas, and you can bounce your ideas off of them, like an FRC mentor, basically. So you have people who will help guide you to the solution without just giving you the solution, and that is, I think, the value there.
So Flatline's Intro to Robotics course. What age group is this designed for, and why is that age range ideal for learning robotics?
So it's hard for me to say that there's an age range that's ideal for learning robotics. There are going to be people who are savants and people who are slow. So neither one of them, like I know people who got into something late and they were slow to pick it up and became masters. So that doesn't necessarily mean anything, but we're looking at late teens, probably 13, 14 and up for this, because you have to be able to work in a group as an adult, right? You have to be able to function like a grown-up does, right? Well, okay, like a well-trained grown-up, right? We've all worked with people who did not function like adults, right? You have to be able to get along. You have to be able to accept when you're wrong. You have to be able to discuss things politely and coherently with people, right? You can't just bully your way through. It's a collaborative process. Everybody's needs to be friends here, or at least civil with each other.
Right.
So that's really the need for the age range, is the ability to work in an adult environment, basically. I've known people who are young, who have tons of aptitude, and there could be exceptions made if that's the case. But generally speaking, ideally you can solve a triangle, like Pythagorean theorem, know that sort of stuff. You have to be able to read and write very well, because of communicating. Everything is written, right? We live in a world where you have access to all of the information at any time, and you have to read it. Not everything's going to be a YouTube video, but a lot of it is, right, these days. Even still, I just put it on 2x and hit closed caption.
So true.
But yeah, you have to have good communication skills. You have to have basics in math. Like you need to know what algebra is, really. Maybe not for this particular introduction class, but once you get past that, as soon as you have to solve a real problem, there's math involved. You need them to be able to know, oh, how do I calculate the tip speed of a weapon? Or how long does this lever need to be to achieve the correct ratio of leverage, right? In order to solve a problem, right? In real life, every problem is a word problem. So it's really the maturity and mathematical skills that are the age.
Parents might be asking, will my kids really be able to build something that's theirs to take home that they can expand and learn on even after the class?
So the Intro to Robotics class, the class robot is quite expensive. So we were not going to send those home. Collaboratively, after that, they'll be able to build whatever they want, ideally. We have thought about adding like a small design section just to give kids the ability to make something to take home, like a very simple combat robot or something like that. Because that can be done relatively quickly without making the class take too much longer.
Now let's talk about the students for a second. What real-world engineering skills will students walk away with after 3 months?
Okay. So kids will learn how to work in teams, how to assemble a robot. They'll learn the fundamentals of mechanics, electrical, and autonomous system design. The focus on real-world engineering skills comes after, where it becomes more about project management, resource management, team management, and working through problems that don't have clearly defined goals.
For students who want to compete in robotics later, how does this class prepare them?
The Introduction to Robotics class by Rev gives you everything you need to know to start working with basic robotics, and also introduces you to the types of materials and equipment that you'll use in competition robotics. Rev is first and foremost a competition robotics vendor. So this is a good head start on that. you'll have an idea of what you need to do when you join a team. It's important to note that the teamwork in competition robotics, much like here, is about more than just engineering though. And an FRC team takes many skill sets like fundraising and communications, as well as just engineering.
How does robotics spark confidence in kids who may not see themselves as tech geniuses yet?
Modesty is a good thing. Completing projects builds confidence. Solving problems builds confidence. And the more of those things you do, the more you'll believe in yourself. So after you've completed a couple of projects, you're probably going to feel a lot more confident. And not every project is going to succeed, of course, right? There's going to be failures from time to time. But it's important that when we have those failures, that we do the right things, like postmortems and retrospectives. Where did we go wrong? Why did this project fail? What could we have done differently? These are things that you do in successful businesses anyway, where you go back and look at what caused a system to fail, right?
Perfect.
Not every project's going to work, and you got to know why.
So that's the robots. Now let's talk about the human side of this. What's one of your favorite teaching moments you've ever had with a student in robotics?
So in general, when I'm teaching, I always really value that aha moment when you know that the student actually understands what you're saying fundamentally, right? It's a lot easier. You can get someone to go through the motions, and they don't have to truly understand it. But when you can see that shift in their thinking, that's what I really love. That where you've made a difference.
How do you recognize when a student finally gets it and starts thinking like an engineer?
I mean, it doesn't happen overnight, right? There's so many aspects to thinking like an engineer that it's like an iterative process. You build on it, right? You're not going to start out knowing everything, right? You don't even know what you don't know yet. That's why we do the survey course, is so you have some vague idea of what's out there.
Now, tell me about the culture and the environment you're building here at Flatline Robotics. What's the teaching style like, and what makes your instructors different?
Well, the culture we're trying to build is one from the robotics community. Robotics is open and welcoming and helpful and friendly and inclusive and eager to support your development. And it doesn't matter whether you're going to BattleBots or whether you're going to FIRST, it's the same thing. Everybody's in it for everybody. There's a lot of camaraderie, and you can get support from people who aren't your teammates, right? Because everybody loves technology, and they love to see what you can create. And that is kind of the culture we want to emulate. And another aspect of culture we want to emulate is, there was a firm called Bell Labs. It was owned by AT&T. And this was basically, they took 1% of AT&T's revenue and they invested in research and development. So you had people who were just working on research for the sake of working on research, and developing technologies for the sake of developing technology, because they kept the sales and product people away from the researchers. When they determined that they had developed something at a foundational level or knew that could be productized, then they would take it out of the lab and into the sales arena. But it allowed a level of innovation and research that just isn't done anymore, right? Everybody's chasing the bottom line, and the money drives every decision. So we don't have that level of foundational research or even things that people are studying because it's interesting. Even at colleges, it's harder for them to get that sort of stuff approved because of politics or money. And I want to create a place where people can learn and study and research and develop and innovate without restriction. And I mean, money is always going to be an issue, which is why you have to pay. So,
Right.
but to create that open environment that is unrestricted in terms of innovation and development.
What makes your instructors at Flatline Robotics different?
They come from the robotics community. We hire from Combat Robotics and from FIRST people who have experience and are interested and motivated and passionate about the subject.
What advantages do students get in a small group robotics setting that they simply wouldn't receive in a larger program?
Attention to detail and access to the collaborative environment. That's the big sell right there. You can probably learn introduction to robotics anywhere, but what are you going to learn afterwards? If you look at the offerings, there's no serious robotics education outside of colleges and high schools. It's all like you go to the church and your kid builds a line following robot in one afternoon, or you do a summer camp and they get to play with Vex parts for a week. They don't present, and there's no one who's presenting an environment for real continued learning, especially in an unstructured way. And I don't mean completely unstructured, but in like a very loosely structured way. Like you can go to UTA and you can take a course on computer vision, right? Or you can go to UTA and you can take a course on mechatronics or whatever, but that's the only place. You can't learn any of the high level stuff outside of a college or doing it yourself. Because all of like the stuff at all the high school stuff is focused on either competition or very introductory. And all of the non-school stuff is intro only, right? Have you ever seen a robotics class or workshop offered that was not a introductory class? It is always like the Snapology, build Lego robots, or we're gonna build a line following robot today, or it's just that one thing and then you never get to go further with it. And the act of going further with it is where real learning happens, right? It's that, oh, I've learned these things, I'm going to synthesize a problem or project for me to start to work to solve, right? And then you come up with your own ideas and you learn everything you need to learn to solve that, right? Which is different way of learning than traditional academia, right? Because to solve a problem, you might have to learn things that are way above your pay grade, right? I remember trying to learn, I wanted to write 3D games when I was a kid. In order to do that, you had to learn linear algebra. And, you know, that's, as a 13 or 14-year-old, linear algebra is a bit of a stretch.
Right.
So, but having that motivation to do so because you have a goal and an objective makes it easier for a student to find that motivation to really learn these things, right? Instead of when you're in a classroom, half the time they just want to get out of the classroom.
So let's talk about the parents for a moment. Why should a parent choose Flatline Robotics instead of the typical after-school program?
Well, because we're not just an after-school program, we are a organization about robotics, right? You go there to learn robotics, and an after-school program, like I said before, lacks depth. It's going to be just the tip of the iceberg, like doing a summer camp or doing a workshop. You can go and you can build a line-following robot, but that's all you do. You can go, IdTech has a BattleBots class, summer camp, and it's tremendously expensive, but you don't actually do any combat robotics with it. Like they build little combat robots out of Vex parts, like the Erector set parts, like the Rev parts, and then they fight them. Whereas if you look at BattleBots or Norwalk Havoc, all of these robots are bespoke, machined parts, 3D printed parts, right? And they're specific, they're made from things that are specific to that field, right? If you want to learn about something, it's best to do it where you can. And a lot of the time when you do an after school program, you're poking it, right? You're not doing it. You're not, you know, you're not going to study the source code to that line following robot in depth. You're just going to like load it on there, and then they're going to give you a high five and say, "Good job, kids." And you're never going to understand why it worked. You're never going to understand. You're not going to be able to take that knowledge and create a robot that goes from circles on the floor, right? You're going to be missing that all the fundamental details that you need to actually apply this.
What made you come up with the idea to teach this class?
Okay. When we were running our little combat events, our Flatline robot rumbles, kids love it, right? And some kids are immediately taken by it. And so parents would ask me, where do you go to learn how to build these things, right? Because they're fascinating little robots. And so I didn't have an answer for them, because there really wasn't anywhere they could go. Said, well, put your kid in college and hope for the best. So that was what drove me to start on the education project, is so that these kids could have a place to do this. And a lot of the time, they're younger kids or kids who are great engineers don't always think like everyone else. And sometimes it is harder for them to get along in traditional environments. So that is why I want to run an untraditional school. The way that education works doesn't always work for the people whose minds work in this way, right?
Absolutely.
The public school education model does not always apply well to engineers. Albert Einstein was a C student because he wasn't good at it, right? It's a different, being a good student in school is not, it's a skill set that's separate from anything else. It's completely distinct from what you actually learn in school, like the act of taking tests or the act of showing up well to class, right? That's all, like, that's a trained skill that is different from the things that you're actually being educated on.
Right.
So providing an environment for the people who are a little bit different to be able to learn, because a lot of these parents, they have young kids who have been about it since they first saw a rerun of BattleBots, right? They're 5 years old and they know the name of every robot. And that's what they want to do. So those kids are usually a little bit special and need a place to go that can accommodate them.
So tell me, from your opinion, what's the future of robotics education look like?
It's hard to say, but what I'm trying to do isn't necessarily what's going to be the future of robotics education, because I'm not trying to follow the mainstream. I'm not even trying to lead it. I'm just trying to do a thing that I think will work for people who have this interest. The future of robotics education will probably be more classes in college and high school, right? It'll probably become more mandatory than it is. I wouldn't be surprised if we had mandatory how to use AI classes in the next couple of years, just because of the sea change and how everything's moving, right? So I believe that it will become more common in the public field, but I believe it will probably be like everything else in the public space, and that is watered down and made accessible to the lowest common denominator, right? Because schools have to teach everybody. It's not that everybody in that robotics class might not want to be there. They might have to be there. We get to tailor our program towards people who want to be here and who are motivated about robotics and have aptitude in at least one of the fields of robotics. And that makes it a lot easier than trying to teach 30 random kids who all have different interests, all have different backgrounds and all that. Having the education be purposeful and made to people who are about that, I think will improve the quality of output.
What excites you the most about where robotics can take your students in the future?
Well, I mean, I'm excited that it will keep them out of the unemployment line. This is going to be a trade that is going to happen. It's going to happen suddenly. We're not going to have enough people who can do these things, right? I mean, there's never been enough like industrial automation engineers. There are classes of engineers which are almost impossible to find that are required, right, to do all sorts of things. And robotics engineers and automation engineers right now are one of those. It's hard to find really good automation engineers. As the amount of robots goes up, the amount of people who can work on them and design them and fix them is going to go up too. Because there's millions of robots in the world today, right? How many people can fix an Amazon robot? Probably not many, and the people who can probably do pretty well for themselves. And Elon Musk says he wants to deliver 1 billion of his Optimus androids in 10 years. Who's going to fix those? Are robots going to fix those robots? Not to start, they're not. So it's going to be secure employment to people who don't have the aptitude to build them or design them or write autonomous systems, but they may enjoy the hands-on aspect of repair and troubleshooting, diagnosis, and like a car mechanic, right? And I mean, to be fair, a car mechanic is going to be like a roboticist in the very near future as cars go all electric, right? It's the same technology, right? The motors are bigger, but they're still brushless motors that have speed controllers, right? And there's still batteries and there's still microprocessors, right? It's the same thing, but it's bigger. So it's a really useful and comprehensive set of skills that you get out of this and that you can use for all sorts of things. You may want to build your own machines. You may just want to be able to fix things. And after you've put together some robots or fixed some robots, you can feel a lot more confident about taking apart or fixing other things. Or maybe it's servicing your car, fixing your dishwasher or your washing machine. These are skills that used to be commonplace. And then everything kind of had this digital sea change and they became less commonplace. But I think that there's going to be a return to that, right? To where those skills will need to be more commonplace and people are going to need to know how to fix their things, right? They're going to need to know how to fix their car even though it's electric. They're going to need to know how to fix their dishwasher even though it's digital microprocessor controlled. And when you understand the design of these systems, whether it's robotics or whether it's dishwashers, right, you'll have a better ability to reason about all sorts of technology and devices, right? It's hard to say, but if you tell an engineer that an airplane and refrigerator work based on the same principles, they'll know what you're talking about. And it's kind of getting to that point, right? If you tell a normal person, if they ask you, how does a refrigerator work? And you say, oh, the same way as an airplane, they're going to look at you like you're a crazy person.
I get that.
So it's like developing those models in your head and the ability to reason about the way things work.
So tell me, what's the bigger mission behind Flatline Robotics? And where do you hope this program leads into the long run?
So I have noticed a shift in our society. So I have concerns about the actors and their motivations in technology. And I would like to create educated people as a bulwark against that. The more people who understand how the technology works, the more people who can look at something and reason about it, the less likely we are to have people just do evil things and get away with it because people can watch. People will be able to look at their robot and be like, hey, wait a minute, what's this for? Or people will be able to analyze the code, right? There's something to be said about the people who do things that they're not supposed to. that's very important in our society. If you look at, so there's a convention, it's called DEF CON, DEFCON, and it's a hacker convention. This is a black hat convention. Happens every year in Vegas. They also have a convention called Black Hat, which is for like corporate types. But the actual event, DEF CON, is for security professionals, like real security engineers, like hackers, people who are into crazy stuff. And every year they have Voting Village, where they tear down voting machines. They get their hands on voting machines. They hack them. They show you how they can be hacked, right? Voting is an essential part of our society. And every year we tear these machines apart in Vegas and we see that they're full of holes. What happens when there's a billion androids out there and hostile actors decide that maybe their eyes should turn red? Or what's going to happen when someone decides to ship a bad code load to the Tesla fleet? Or having people who recognize these dangers and know how to prevent them and how to mitigate them is going to be essential. So the long-term goal of Flatline is not just to teach people how to build robots. It's to teach people how to deal with robots, how to build robots, how to break robots if they need to, how to reverse engineer robots, how to, as you get along, right, there will be opportunities to do things like reverse engineering and code analysis of existing systems, where we can go in and try to find, did the manufacturer leave any back doors in here, right? And do that. It's a kind of a public safety thing. So having people with those skill sets. And also another long-term goal of Flatline is we're going to need people who can repair robots. And we're going to need people who can design and research and do those things. So having a school where we can teach people, train people, and also have them bring in fresh ideas and new ideas gives us a pipeline for people who can fill these roles that we're going to have, right? Hiring is incredibly difficult in technology. I've been a software engineer for a very long time, and it has always been difficult to hire for that field because there's so many intangible things that go into it, right? Like there's the culture fit, there's the skill level, there's work ethic. There's so many things you have with hiring. So having a pipeline to hire from, where we know these people and they're already vetted and we can just bring them in, right? After, if someone's been in the collaborative learning environment and they've been there for 2 or 3 years and they've done cool things, in that time, and maybe they'll work for us when they get back for college, or intern with us, or maybe they weren't lucky enough to go to college. Maybe something happened and they had to stay home to take care of their parents, and they can work for us out of high school, right? Because there's always going to be a need for people to fill these roles, and they're hard to fill. So being able to create a training system from the ground up and pull from that as a resource, I think will help us to create a healthier organization and one that has the high level of technical competence necessary.
Switching gears, summer camps. What do parents need to know?
We're going to be offering summer camps for 2026 around combat robotics. We've gotten a lot of interest from parents who want to have a camp experience where their kids can design or build a combat robot and fight it. So we're planning on having some offerings around that.
When you imagine Flatline robotics summer camps, what makes them different from typical STEM camps parents are used to?
Well, there is another combat robotics camp that is partnered with the major television program, but all the reviews I've heard of it have been that it's not really combat robotics, that you build with the Vex parts and then you battle and half the class goes and plays Roblox instead. Our camps will be, you build either kit robots for the simpler camps, or you design and build a robot for the more advanced camps. And you will do this with people who have built combat robots before. That is the big difference. You're going to be doing combat robots with combat roboticists. You'll learn with people who have been on the TV show instead of just anybody.
What is it about combat robotics that makes kids instantly engaged and excited to learn?
It's incredibly fun. It's action-packed. It's exciting, right? And you don't really know. Like most of us have seen the show, and it's cool, but you don't understand. You don't know what it is from watching the show. When you see it in person and you feel it, it is a different thing. When you go to Vegas and you see it live, and the entire arena shakes when one of these robots goes up in the air, it is incredible. And the same thing when you go and you fight a 3-pound robot in a little box that's 8 foot by 8 foot, and that other robot hits it and it smashes into the roof and everyone screams. It's amazing. It's so fun. And it's a different set of skills than a lot of robotics, but it's still incredibly detailed. And you spend a lot more time on material science, I think, in combat robotics than you do in a lot of other forms of robotics, because a lot of it goes into durability and like weapon design. And kids aren't going to know this off the top. Like when they're watching it, they don't care that blade is AR-500 and that one's F7 steel, right? They just care, like, wow, boom, explosion. But when you get into it and you try to build one, then you have to start learning, oh, well, I got to use PLA here because we're fighting plastic ant weights, right? So all my stuff is PLA. I can't use urethane. I got to use PLA plastic, and I got to use these parts for this. I'm going to make a 3-pound robot. Well, this needs to be AR-500, and this needs to be TPU 3D printed, and this needs to be water jetted carbon fiber, right? So you learn a lot more about the material science and the physics and stuff like that, of like impact and like force mitigation and stuff like that. But yeah, kids love it because it's awesome.
Nice. What's the difference between a simple Lego Fight Club experience versus the more advanced kit building camps that you're talking about?
I mean, Lego Fight Club is pretty exciting, and Battle Bricks is a lot of fun, but necessity is the mother of innovation, right? So you think about things differently depending on whatever you're doing. When you work in Battle Bricks, you're constrained by, I'm using Technics motors and Technics parts and regular Legos and Mindstorms or Spike today is what it is. And that is a lot of constraints, and you're really limited on what you can put out with like a battle brick, right? Even a 3-pound Lego robot isn't that powerful, right? Their motors aren't meant to do that. But in a regular combat robot, everything can be whatever it can be, right? And if you look at the advent or the change in availability of power technology in the past 10 years, I can buy a motor that is 2 horsepower that fits in the palm of my hand and weighs 15 grams. So my 1-pound robot can have 2 horsepower of output. Now it's not going to last very long because the battery is only this big. It's going to burn it, but you can deliver an absurd amount of energy in a 150-gram robot or a 1-pound robot now, when you don't have any of that capability in the Lego League, right? So you have to plan differently, right? And your engineering is different. Whereas in the Legos, you know that they're only going to be able to spin this fast because they all have to use Lego motors, right? You get out of that, it's like, well, you might be fighting plastic ant weights and everything's 3D printed, but that one, that piece of plastic is spinning at 12,000 RPM. And it's going to deliver, thousands of joules of power to your robot when it hits, and there's going to be significant damage. And how are you going to deal with it? What do I need to think about when I'm building a robot that's going to be hit by that thing, right? It's a different set of design constraints. I think it's more fun. It's definitely louder, a lot more action, because there's so much more force. You get a lot more like roof shots and robots bouncing off the windows and stuff like that. It's a lot more energetic than Lego BattleBots.
So, the summer camps, there's different kinds. What do kids take home after attending the camps?
The robot they built and lots of good memories. Well, what's left of the robot they built? Lots of good memories.
That's so good. That's so good. But now they know how to do it again.
Yeah.
There you go. Tell me about the BattleBots Bound idea. What would that experience look like?
That is an experience for the truly dedicated. You will spend weeks with people who've been on BattleBots before building a full-size 250-pound combat robot. All in, all expenses paid, take it to Las Vegas, fight it at Destructathon, win or lose, and really experience the full combat robotics experience at its highest level.
Now, let's talk about Robot Rumble events. What is a Robot Rumble party? How would you describe it?
A Robot Rumble party is a gathering for people to fight combat robots. What we do is we bring our arena out and a whole bunch of 150-gram ferryweight sportsman robots and allow you to fight them. Depending on the age group of the party, it may just be an open melee where kids can just battle to their heart's content, or it may be a tournament where we have brackets and people compete to see who the best competitor is.
What inspired you to bring combat robotics to birthday parties and private events?
It's a lot of fun and people don't get to experience it. And everybody who sees it loves it. So it's partially a labor of love trying to grow the combat robotic community here in North Texas, right? We have a pretty great community, but it could always be bigger. And some of our weight classes are not as full as we'd like. So we try to drum up interest and spread the love.
What does a typical Robot Rumble event look like from start to finish?
We'd like to show up about 30 minutes ahead of start so we can get all set up and all of our arenas hooked up. And then we begin. And in a case of a melee with younger kids, the kids will just pick up remotes and start playing, and we'll run crowd control and shout fun things at them. Give them some of that commentator action. One of the fun things about the TV show is the commentators. They're a lot of fun. And so giving the kids a little bit of that experience is also very fun for us. So we like to, we'll give them commentary and, cheer for them and shout. It makes it a much more interactive experience. Because if you've been to a real event, like a competition here in Texas or to Destructathon in Vegas, the crowd goes nuts. And it's an important part of it. In terms of making it more fun, having people shouting makes it fun.
So you have so many different types of robots and controllers for these Robot Rumble events. How do you make the experience accessible even for the people who've never touched a robot? Is it something they can pick up intuitively?
Yes and no. So we have developed technology for our robots that allow them to run on Bluetooth controllers. So for our youngest competitors, we like to give them the PlayStation controllers. They're knockoff PlayStation controllers. They're inexpensive. They drop them, I'm not out a ton of money, and they're usually familiar with it. They pick up a PlayStation controller, they know what it is. When you pick up a model airplane controller, which is the other popular controller used in combat robotics, there's a lot of switches and a lot of settings, and it can be very daunting. And they also cost a lot more. And so when a kid drops one, they're also a lot more fragile. So when a kid drops one, it's a $60 loss versus a $5 loss for a PlayStation controller. That said, the robots are all two-wheel robots, and two-wheel robots are just hard to drive. So we tend to leave the speeds down on them so they're not as fast as they could be, so that it's easier for kids to get a handle on it. But it does take a little bit of work to get used to driving it.
Okay, but the PlayStation controller makes the learning curve a lot quicker.
Instead of like, I have one here back there, the controller, you can see it's got a lot of switches on it.
Right, yeah.
And it's its own display. And they like, if they hit the wrong switch, it'll like invert the driving, right? And stuff like that. So
More advanced.
yes.
What makes these parties fun for both kids and adults?
Well, when adults are willing to play, they have a lot of fun. I've noticed sometimes at public events, adults will like stand back. Like you can see that they want to join in, but they're afraid. Our game is fun for everybody, young, old, it doesn't matter.
How do you keep everything safe while still making it exciting?
So we don't run fully destructive robots, right? So the ones we bring to the melees are sportsman class, meaning they're flippers and grabbers. There's no spinning weapons that can throw shrapnel or hurt anybody. We also bring our own fire suppression system. We have fire blankets, we have a first aid kit, we have fire extinguishers. There is always a small possibility, as with any piece of lithium battery power technology, like your cell phone, that if it suffers damage or over drawdown, there is a slight fire risk. So we always bring the means to address that. In the combat robotics community, we're very capable of dealing with these situations. We deal with them in crowded venues all the time. It can be a little disconcerting to watch, but generally what you'll see is we'll grab the robot, throw it in a bucket full of sand, and take it outside. And that's all that has to happen. Lithium cannot be extinguished when it burns. So the only thing you can do is bury it in sand and let it cook off. So that's what we do. I've never had a battery burn at an event.
Okay.
The smoke has always been melting Lego rubber on servos.
Okay. Okay. At a Robot Rumble party, what kind of space does someone need for you to set up?
We like a 10 by 10 at a minimum. We like to be able to secure our backside. Usually what we do is we'll have the arena in front and then have tables flanking us. Because we have a lot of battery charging in our own equipment, and there's a computer that all the robots connect to for monitoring, right? So there's several things that have to be withheld back. So we like to box ourselves in about a 10 by 10 foot space. Usually we like a little bit more. And we can stretch out further if you want us to bring displays or other things.
So a hard surface preferred, but is on the grass doable as well?
Yes, the grass is fine.
Okay. Okay.
We prefer
Table on top, so it's all good. Okay.
We bring everything, right? We have our own tables, our own supports for the arena, our own electricity, everything.
What reactions do you typically see from people during the first robot fight, kids and adults?
Lots of cheering and shouting and excitement. Kids go crazy. And a lot of the time, it's like a progression, right? Like the young kids, a lot of times they'll never get past the like just making the robot go crazy. But the older kids, they start to like understand it, and they like start developing tactics or like strategies and stuff. That's always very fun.
Why are Robot Rumble parties so memorable compared to traditional party ideas?
Well, have you ever been to one?
I haven't.
Exactly. So first off, it's new. People don't do this. There's only a handful of other people in the country who are doing similar things. The first one was Zach Little from Scorpios, BattleBots. He does it over on the West Coast. And there's another firm that does it on the West Coast, but nobody on this side, this part of the country. So it's kind of unusual, and it's super fun. Like kids talk about it afterwards. Most of our gigs come from people hearing about us from someone else, right? Because some kid would not stop talking about it. Or like we did a PTA event because they saw us at it, and mom really wanted us to be at this event because of how crazy the kids were going for this stuff. It's a lot of fun.
I love it, man. I love it.
Yeah, we have a lot of fun. This is really, really fun to do, actually. Like, it's super fun to put on these events.